Partial fraction decomposition, a mathematical method to simplify a rational function. We use this when we get a complex rational function and we need a way to break it down and make it easier to solve. This is very useful in terms of finding derivatives of functions and integrals of functions. We can use partial fraction decomposition when the power in the numerator is less than the power in the denominator. There are 5 different forms a partially decomposed fraction can take. So look at an example of the first form. Let's look at the function negative 5x plus 4 divided by x squared minus x. Now, it might not be evident at first that this fits form 1, but what happens if we simplify the denominator by factoring out an x? The numerator will stay the same, and as far as the numerator goes, it's somewhat irrelevant in terms of doing a partial fraction decomposition. It's relevant in the sense the power has to be less than that in the denominator. But otherwise, you aren't really going to use it in terms of what form you're going to use or what form the fraction is going to take. It's really all about the denominator. So if we factor an x out of the denominator, I get x times x minus 1. And this does fit form 1. So I can say this is a over, instead of saying x minus a, I'm just going to say x plus b, and instead of writing x minus b, I'm going to say x minus 1. My next step is to simplify it, and to do that, I want to get rid of this denominator. So I'm going to multiply it to each side of the equation. That cancels out on the left side, and parts of it will cancel out on the right side. This x will cancel with this x, and this x minus 1 will cancel with this x minus 1. This gives me the function negative 5x plus 4 equals a times x minus 1 plus bx. Once in this form, it's easy to see I have 2 unknowns, but 1 function. So how do I make this solvable? I do that by understanding that this is a function, and x has a value at any given point on this function. And so I will pick values along this function to allow me to manipulate it to cancel out certain variables to make it solvable. What I mean by this is, let's let x equal 0. What's that going to do to my function? The left-hand side simply becomes 4. The right-hand side becomes negative a plus b times 0, which cancels my b out. This allows me to solve just for my a, which you can see is negative 4. Now that I've solved for my a, I can plug it back into the original function and pick any other value for x to now solve for b. So to make the math simple, let's let x equal 1. The left-hand side of this function becomes negative 1. The right-hand side of this function, this term actually goes away. It goes to 0. And then I'm left with simply b. So b equals negative 1. I can now plug this into this original format using this right here as my guide. I get negative 4 over x minus, instead of plus because it's a negative 1, 1 over x minus 1. And this is the format for a partially decomposed fraction taking form 1.